talk session of the conference. We have 6 talks for you. Each of them will last 10 minutes, and then we have time for questions for 5 minutes and switching of presentations. So the first one is Auriel. Auriel Hiri, and she will talk about authentic science in the classroom.
Good morning. Yes. Now, what I'm talking about today is quite a variety of different activities that we've done on a way that I think is really important in terms of teaching children science. In fact, teaching children just about anything, and that is that if it's authentic, if it is something that has a real purpose and has part of society, it's something that they can contribute to society. And I'll just give you a couple of examples. Right now we're doing one. It doesn't have anything to do with astronomy as such, but we went into the city the other day with my class and we mapped out, got GPS readings and lots of information about all the street art that's around. And they're producing a map for the Perth City Council. So that Perth City Council map is going to be for tourism and for teachers, because teachers have been saying, look, where can we go in the city? And they've been ringing the Perth City Council. So it is an authentic experience that has some really positive outcomes. My argument is that their level of learning improves considerably. They start to achieve and start to demonstrate a much higher level of thinking, because it is very much inquiry, but it is also very much skill-based as well, because they find they can't produce their map if they don't understand latitude, longitude, mapping skills, legends, and so on. So this one here today is on different aspects of astronomy. I just have to recognize before I do that the part to do with asteroids, is part of my PhD, and I have to acknowledge the help of Professors David Blair, David Coward, and Grady Venville. The rest is just my own stuff. All right, now this is not up here because I think everyone wants to look pictures at me. It's got to do a lot with you can be more than one thing. You can be a teacher and you can also be in science. You can be an artist, a musician, a scientist. You can be a lot of things. You don't need to limit yourself to one thing at any one time. And when kids see this, they start to think of themselves, instead of just thinking, oh, I just want to follow a music path, they can go, oh, but I'm also interested in science. I can do both. The bottom left-hand one is one that will come back again. There are a lot of things I did. We used a spider at school. That's a climbing frame to do the top one, the top activity. And the bottom one I made bubble spacesuits out of white bubble wrap, industrial strength bubble wrap. And it works brilliantly, absolutely brilliantly. But neither of those were authentic science, they were just activities. The bottom left-hand one, though, is simulations, and that was a science activity, which we'll come to. All right, asteroids. The big difference between the asteroids that I'm doing and the asteroids that I think most people do is that my students are actually finding their own part in the sky. So they are really learning about right ascension, declination, distances, all those sorts of things, but they're also learning how to use telescopes. So while they are learning those things, now my kids and we have different goals. My goal is that they will learn about science and astronomy and have a really good knowledge of the sky. Their goal is that they will find an asteroid and be able to name it. Now, I don't care that we have different goals. What I care about is that at the end of it, they have learnt a lot of science, and that's what's coming out of it. We're using telescopes. The one in the middle there is the Zadko telescope. That's a scientific one. That is the biggest hit with the kids because that is the same telescope that scientists use. And you can never underestimate the power that being able to use equipment and do things that scientists do in the way that scientists do it has on their learning or the impact. And the others are telescopes that we have in UWA that are, they are at UWA, but they're available for teachers. Now this one here is just a straight image. I've just taken a couple of images that they've done recently looking for asteroids. But what they do is they actually go out. So we did a lot of background work to start with on what asteroids were and how to find them and things. But instead of starting at the beginning, I always start in the middle. I always start with the fun part, and then I build on either side of it. So in this case, I started with looking for asteroids, but I started by by doing night sky stuff. We used Stellarium to find interesting objects in the sky, and then once we started to look for them, they started to be able to say, oh look, I think we're going to find it really, they'll look at big sky maps that are already done, and they look at surveys. They use the Minor Planet Center, they'll use JPL to find their information, to find out where some things are or where work's already been done, and then they'll look at it and say, and this came just recently from one group of my kids, we're going to look around the Southern Cross because there is not a lot of work there, but there's a big dark area there. So there are some places around the Southern Cross with a lot of stars, and it's difficult to find things, but there are also very big dark areas. So when they can give me that sort of logic, I know they're really starting to understand how to do astronomy. Now this video just shows you the reason I've put the little minor planet part at the top. Now we've got UT time, we've got universal UT time, right ascension declination, which you can link to latitude and longitude on the Earth. You've got position of the moon, position of the sun. There are so many things there that include analytical thought. And my kids are year 6 and 7. So that means they're about 11 to 13, somewhere turning 11 and then turning 13 in that way somewhere. Now this is just a group, I've just put this on, there's no sound to it because I'm going to just talk to it in general. But what they're doing is they're working with each other and they're finding different places using Stellarium. And as they're looking for different places, they're also looking for parts of the sky that match some of the research that they've done. Once they've done that, you'll see then that they move on to looking for telescopes. You can see there that someone was just pointing out that they had the right ascension and declination. Now what she was actually doing there was saying, oh, we've got to make sure we get the one with 2000 because Stellarium has 2 options for it. When I heard that, I knew that that group had totally registered because I had done some work on why we needed to look at the 2000, why we did not need to look at the other one. So for them to say, oh yeah, look, this is the one we need to do, that shows me that they've got quite a high level of thinking going on here. But this is just an average class. You have to keep that in mind. I'm not talking about extension classes or specialist groups because I tend to not do those. I tend to be the person that wants to give it to everybody in your class because everyone is going to get something out of it. This one here, they're actually matching the 2. So you'll see the screen on the right. That one there, they're on the Minor Planet Center. So they're looking for the Minor Planet Center. Whoa, okay. They're looking for the Minor Planet Center, and I'm going off that because we've got a lot more to get into here. These are just some of the images they took, but when they did it, we talked about dust lanes. This is the butterfly cluster. They talked about open and closed clusters. They talked about how far away things are. This was merging of galaxies. So at the end of this, when they were doing this sort of thing, they were learning a lot about the universe in general. And that was so they would be really interested in asteroids. That was really only something that I did. I did all the astrophotography and bringing up the galaxies and things and deep sky objects because little white dots on a page are just not that exciting. But they become exciting when they start to learn about how they fit into their universe. Now, we also did the Lunar Orbiter project, another real science project, authentic. We got access to the Lunar Orbiter. We were able to take all our own images. We took all sorts of images. They learned a lot about the moon, but some very important things. They learned what we know now may not necessarily be what we know tomorrow. For example, there were parts on the far side of the moon that were expanding, while parts on our side of the moon that were shrinking. And for them, that didn't, that was something new. The thickness of the moon was less than we thought. It has great areas of mass concentration. So there were lots of things they were learning just doing that, and they were doing it as a scientist. They were taking images, they were able to exchange information with scientists, and with other schools around the world. This one here is using EarthCam. Now, the scientists use EarthCam for the same reason. This one is very recent. This is the flooding in Pakistan on the Pakistan-Indian border. What my students were doing with it, we were looking at things like erosion. So they've actually taken a number of images. We've got 2 more. Every time an option comes up to use it, I grab it and we come up with a different thing that we're doing it for. You can see we had rivers at one stage, we had erosion, we've had land masses, and so on. But what they can also then do is link it over the top of Google Map. So you've got a whole mapping thing going on here as well. Now, this one here, sometimes you would think, gee, how does your robotics, which is obviously not completely authentic science, fit in with authentic science? But it does. Because before they designed, we did a lot of work and saw a lot of videos on how they designed and what they did to do to design the Curiosity. And then they got all their gear together, and now I'm setting up a big Mars thing outside, and they've built robots. And there've been a lot of time discussing. There's a lot of time, you'll see the moving windows, wheels, they talked about kinetic energy, they talked about movement of things, how it's going to go, will it go over rocks? We probably won't get time to get that whole part of the video in today, but here he's decided to use a double motor, double omni wheels on the back to get over rocks, but to have heavy ones on the front to get over the sand areas. This one here, this has got tech drawing in it. It's science drawing as well. And with the science drawing that's involved, you'll see he's actually got a picture in front of him that he's drawn. He's labeled it, he's drawn it. It is really high quality. He's not my best student, but it came out of what he needed to do there. There they all are discussing it. If we'd had time, you would have seen Afar and do a little happy dance in the middle of it. This was the one I had alluded to at the beginning. This is some work that we did. I've been doing with electronics with my year sixes, because year sixes electronics is in their program, or electric circuits. We're actually building a simulator. I'm doing an Astrofest towards the end of the year. They are building a simulator. They've done all the background work, and now all they need to do is set up the panels, set up the switches, build our simulator, and then people can come in and do it. And that is authentic science, because for me to be co-pilot of some work I was doing in astronomy, as an astronaut, we had to use simulators. You use them a lot. Thank you. Any questions? See, my email address is right there. Thank you, and obrigada.
Any questions?
I wonder about you integrating more with Patrick Miller and that asteroid search somehow.
Yeah, I'm thinking about that because it will increase their chances of finding it. But my focus was really on giving them the opportunity to understand the sky.
Actually,
but now I want to move on.
All due respect, I think the educational scaffolding you do is currently not done in Isaac, and I think Patrick and Isaac could benefit a lot by the kind of stellarium and understanding coordinates. That's all hidden from the kids right now. So this is really super.
That's why I want to do it this way, and then add the big picture at the end of it.
Congratulations.
Thank you.
Well, how big is that telescope?
One of them's a 1 meter. The Zadko is 1 meter. And then there are two others. One's a 23-inch, I think, and a 18-inch. And then I've got some others around.
Do they have
as well.
a wide field camera on the 1 meter?
I'm not sure. I'd have to check.
You know, if we could use that telescope for some Patrick's searching, this could he would die for that.
Yeah,
so,
okay. All right.
Thank you so much.
Okay, you're welcome.
Any more questions? Then let's thank Ariel again. And our next speaker is Pedro Burgues da Silva.
I don't know where they are. Maybe here. Right. Yeah, it's this one.
Pedro is going to talk about educational activities development.
Okay. Okay, so good morning to everyone. I'm Pedro. I'm here to talk about our educational activities development we do in Mais Ciências. So First of all, I'm going to present what is Mais Ciência. Mais Ciência is a tutoring center. It's in fact a tutoring center where we are specialized in physics and maths. It is my background. I have a background of astronomy. My colleague has a background of math. So we too are specialized in these two subjects. And we do mostly tutoring for high school levels and college levels. Although we have some students from early stages, we are specialized in these two levels. So, otherwise than this, we also have some activities development. Since I've been working for much time in outreach, we thought that maybe it was a nice idea to implement some activities to, rather than having the schools coming to us, we go to the schools and we present our activities to them. So we mainly have observations. We are starting the classroom activities, and maybe later we have some workshops prepared. But the principal idea of this was interacting these two different subjects. So we want to take effort about the synergies that we can make between the tutoring center and the activities development. Why? Because mainly, since we are deeply involved in the school subjects that are taught here in Portugal, we know exactly what the students know, and we know exactly what the students don't know. So this way we can develop the activities in a more efficient way. So let's talk about our activities, the ones that we had presented in the beginning of last year. We had the solar observations and the nocturnal observations. So we have bought some telescopes, and we created these activities having in mind different goals. For the solar observations, our goals were to have kids from different age groups, to be a broader audience activity. So this way we could have kids from since the 3rd and 4th grade until the 12th grade and high school kids participating in this kind of observations. We choose the schools to be our target, mostly because of the synergies that we have by tutoring. And we wanted this activity to last for 50 minutes, which is about the time of a class here in Portugal. So, apart from this, we wanted to be high efficient. I have done many solar observations in the past, but I think that having a lecture, like a 20-30 minutes lecture before, it's very good for the children to know exactly what they are going to observe and exactly what they are going to learn from this activity. So we do a class. Inside the class, we do a previous lecture, about 20-30 minutes. Then we ask the kids to come with us outdoors and to look through the telescope in order to observe the sun. We have 2 telescopes for this activity. We wanted also to be something to be remembered. So we wanted also to have something the kids could take home with them and look into it forward in the future. So this is a picture of one example in one of the schools where we have a Lunar 60 millimeters telescope, solar telescope, H-alpha telescope. It's an amazing telescope. We can see the very details of the sun. We can see the spots also, and we could see mainly the proeminences of the sun. So apart from this, we have another backup telescope with a solar filter, a normal telescope, a Newton telescope with a solar filter to look into the sunspots more closely. So we have this kind of activity separated or divided in 4 different age groups. The first is for 1st to 4th grade. The second is 5th and 6th grade. The third is 7th, 8th, and 9th grade. And the last one is for high school students. We have the different, sorry, this is in Portuguese, but the context of the lecture is well determined, and we have a different lecture for each of these of these grades. So apart from this, we have a flyer, a 4-page flyer that we handle the students so they can have it, and if they are interested to read it and to gain more knowledge about what they've done and what have they looked into, I think this is a very good way for kids to remember what they've done in such activity. So the night observations or the nocturnal observations are a bit different because they really need to be at after-school schedule. So we don't, it's logistical impossible to have them in a normal classroom. So this way, we designed this activity to be presented to a broader audience. So the main activity, main idea is to invite the parents to come to the schools. This way, they can have like a star party, having the kids and the parents. We can also give a previous lecture. In my way of thinking, it's a very important thing because we can teach everyone how to look through the telescope, because there are many people that don't really know how to look through the telescope, and there are many kinds of different telescopes. So this way, when they go to observe, they really know what they are doing, and they really know what they expect, because in our internet era, we know that mainly people think that they are going to look through the telescope and they are going to see that beautiful Hubble images, and that just doesn't happen. So I think it's nice to prepare people to know exactly what they are going to get when they look through this telescope. Otherwise, they will be a little bit sad because they couldn't see the colors, they couldn't see all those bright, shiny objects. So, no. So this is a photo taken from our last observation in Sinfãs, and we have handled this flyer about our activity, and we have a 12-inch telescope for doing these observations. It's a bit heavy, but I think it's worth it when we go to places where we don't have light pollution. So for this year, we are programming the classroom activities. The goal for these activities, they are designed mainly for high school, at least this year, because probably later on we can develop some activities for the previous years. But we want mainly to use real data. So we are going to collect real data. We are going to make these activities mainly on astronomy, of course. And we want them to use computers, use Excel, for example, or some similar project. The time of this type of activity would have to be two classes time, because 15 minutes, I think it's not enough for this kind of activity. So maybe 2 classes, I think it's probably a nice time for doing this. We have an introductory lecture. Then we handle the protocol so they can follow and they can do the work. And of course, at the end, they will debate the results amongst our team. We are preparing 2 types of activities. First, the exoplanet surface temperature. Exoplanets, it's a field of astronomy that's in high development right now. And they already know, high school students already know the concepts as Albates, sphere surface area, and the radiative power, Stefan Boltzmann radiative power law. So with this, and having new concepts in mind, like what is the habitable zone, what is an exoplanet, what are the different star types, we can have them calculating from real data the surface temperature of some of the known exoplanets. Apart from this, we have also black holes gravitation. The same way they have some known concepts, we introduce new concepts, and then from real data they can extract some real scientific knowledge, and they are working really with scientific data, which I think it's very, very amusing. So later on, we are thinking of developing also some workshop for students, like an evening and a night of observation, and for teachers also a workshop for how to use a telescope. Because here in Portugal there are many schools that have telescopes that were bought some years ago. Then the teachers went to other schools and the telescopes are stopped and gaining dust, and no one in the school knows how to work with them. So this would be a nice way to put the instrumentation we have in our schools working. So, future developments. To end, we want to increase the number of activities, of course. We want also to go to scientific tourism. I think Portugal is a very nice place to improve this kind of activities with tourism. We want to make some new national partnerships, international partnerships, and we also want to make some apps development software for using in our activities. So, thank you very much.
Any questions? I have a question. So, how do you deal with night observations and clouds? Do you plan them beforehand, or just on the same day when you know it's not going to be cloudy?
No, the night observations in class, we can make it for students, of course, and we have all planned before. We just organize them like after dark. We can give the lecture before, and then we invite people to look through the telescope, and we explain what they are looking at, of course. Yeah.
Any other questions? If not, let's thank Pedro. Yeah, there's one more.
I'd like to know, where do you do these night observations, and where is the center?
Sorry?
Where is the center of My Ciencia? And
My Ciencia is in Gaia, Vila Nova de Gaia.
And you do the night observations there?
No, we don't do the nighttime observations. We go to schools. We don't do it in our place. We all of our activities are to be done outside our center. Yeah.
Any other? Okay, let's thank Pedro again.
Thank you.
Our next speaker is Emilia Ortiz-Gil. Emilia is going to talk about A Touch of the Universe.
Hi, well, I'm going to talk to you about A Touch of the Universe, although I think that most of you already know about this project because you have had the chance to see the materials outside and talk with Lina about it. But anyway, I'm going to give you an overview of it. So, Touch of the Universe is a non-profit project to build and send 30 kits of tactile astronomy materials to be distributed among educators and teachers in underdeveloped countries in the Americas, Asia, and Africa. Here you can see all the boxes sitting in my office while we were struggling to get some funding to finally send them out. And, okay, this is a kit for tactile astronomy, but it's not restricted just to blind students. Anyone can use it, and anyone can benefit from the experience of learning while touching and listening. So I tend to see this not like as a project for the blind, but as a project for many people, including the blind. Okay, this project has been made possible thanks to a large team of people who have contributed in different ways to it. I'm just the coordinator, and the important people are the ones here. A few of them are around this hall here today. So this is a project which has been funded mainly by the IAU's Office of Astronomy for Development, but we had funding also from some other organizations and also some other kinds of support. You can see them here, but I would stress UNAUI, GTTP, Astronomers Without Borders, and the Osservatorio Astronomico di Brera, Nosocolo di Padova, Eurastro, the Galileo Mobile, here Maite, and My Ciencia. I just met Pedro here. Thank you for your help. So what is in the kit? In the kit you can find several items, which are these ones: the Sky in Your Hands Planetarium Show, the Tactile Moon, an activity book, Chandra's From the Earth to the Universe tactile prints, Norengri's The Little Moon Facebook, models of constellations in 3D, a DVD with a planetarium soundtrack, different languages, and then several guides. So the Sky in Your Hands Planetarium Show, it's a planetarium show that we planned for the IOIA 2009. And we premiered the show at the Valencia Planetarium, at the Hemispheric, and then it was shown in other places of the world, like Puerto Rico, or in Portugal they show it at Espinho Planetarium, and also here at the Lisbon Planetarium. It's a planetarium show thought for the blind. So it consists of a soundtrack, which is recorded in 7 tracks. So you can hear the sound effects which are associated to each object as coming from the place in the dome where the image is projected. And there are also 2 people who are, one is narrating the scientific content, and the other one is guiding the public through the tactile material. So this is the tactile support material. It's a half sphere which has some constellations engraved on it, the constellations and objects that are featured on the show. And okay, there are some things that help there to the blind people to go through to explore the sky. Dash lines take you from one constellation to the next one. Then continuous lines are the drawings of the constellations, and then the small balls are fainter stars, the larger balls are brighter stars. So in this way, the public can feel the shape of the constellations while they are listening the description and the story related to it. So, as I said, it was premiered at the Hemispheric, which is a very nice theater in Valencia. The Tactile Moon is a moon in relief. It's not a topographical representation of the moon. It's more a tactile translation of the visual impression that one gets while looking at the moon. So we wanted to tell in a tactile way to these people what we are able to see. So, for example, the crater rays, they don't have any relief in the real world, but they do have a relief here, so they can learn that the craters have rays because they are so conspicuous when we saw them from the Earth. We also thought of a way to help them to autonomously explore the moon. And we marked a few features with Braille letters, and then we accompany the moon together with a document which has a legend. So each Braille letter on the moon corresponds to the name of the feature that one can read on the document. Mm-hmm. So in this way, they can explore just by themselves the moon without the help of anybody else. Also, we have marked the north and south poles in order to help with orientation. And there is also a meridian, which is separating the near side from the far side. So we also build these models of constellations in 3D. In fact, I think these ones are probably more useful for people who are sighted than for the blind people. And they just show the fact that stars in a constellation are not nearby, and they can be very, very far away, in fact, in reality, in the universe. We also created an activity book. It has some ideas about what kind of activities can be carried out with materials inside the box. So this is just meant as a first guide, just a starting point for the teachers and educators. Then we expect them to be able to build upon these activities to make their own according to their particular students or public. Mm-hmm. The book is made also in Braille. You cannot see it here, but it can be touched too. So, okay. These are, I think most of you know these things. Okay, thank you. These are the tactile FETU prints from Chandra project. They were given to us by Kim Arkan, so that we could use them. There is also a little book about the moon phases, which is made by Noreen Greases. The book is not edited anymore. It's a pity they are not printing it, but this author has lots of very nice tactile books on astronomy. Then there is a DVD where we recorded the soundtracks of the Planetarium Show. We have them in English, in Spanish, and in Portuguese so far. So any one of you who wants to translate it, you are welcome. You can contact me and we can work on that. And there are also some PDF files related to the materials, to the FETU materials, and guides to the Planetarium Show and to the moon. And we also printed a few guides for the moon and the planetarium so they can learn how to use it. Okay, it's been sent pretty much all around the world. I'm very proud that we got a box in Iran, which I thought it was impossible. I was told it was impossible, but we managed to send it to Iran. And then now Nepal, India, and then Ethiopia, Zambia, or Brazil, Colombia, many places. A few of you have received one too. So there's just some pictures of people trying the kit and working with it. We tested a few of the materials here in Portugal with Lina. And then these are pictures from the kids making the activities in Nepal, in Costa Rica. There is also some guidelines. We are providing some guidelines to produce this half-sphere by hand. So it's a nice workshop to do with the children, that they can make the half-spheres also for their blind peers. So they can, the sighted children can make the half-sphere, and then that will be used by the blind friends. South Africa, Argentina, India, Colombia, and finally this one from the Galileo Mobile. Thanks, Maite, in Bolivia. And okay, this is the webpage of the project. And a few of these materials are available for downloading. So if you have a 3D printer, I'm happy to send you the 3D files of the moon and the half-sphere. And the activity book can be directly downloaded from the webpage. And, well, anything you need, I mean, just contact me, and I'll be happy to help you or receive your suggestions or whatever. Thank you very much.
Any questions?
I have a question, and perhaps the answer can be either inspiration or bad luck to those that want to follow your way. Do you have strong institutional support to pursue this kind of activity, or you do it in your lunch breaks and coffee times?
Now, I'm very lucky. In my observatory, the director is very fond of anything related to outreach. And they are really very keen on doing this kind of things also because it's a different kind of outreach and it's reaching some people who are usually underserved. So, I'm strongly supported. I'm very lucky with that.
Let me tell you that I've been to some conferences about science education, and what I hear is that is not only look good for visually impaired children, but to learners as a general thing. Being able to listen, see, and touch is very important for the learning curve.
Yeah, it has been shown already that the learning process is greatly enhanced when you involve more senses. So I think it's really important to do this. So I think there is something called the universal design of learning. So I think we should go for it. And it's because it's enriching not only for the disabled people, but for everyone. So we should go for it. We send a call through the UNAWI and GTTP and AWB networks to tell the educators that these kits were available and send us their request. And yes, they made their case and said, well, I'm going to use it in this way or that way. And from there, we chose the 30 lucky people who got it.
Okay, congratulations.
Thank you.
Have you think about don't to use the stars in the convex side of the sphere, but in the concave side?
Yeah.
Because of the shape is opposite when you touch, and we can touch by inside of the sphere. What do you think about?
Yeah, we had lots of discussion about this when we were developing the program. And we finally agreed that it was more difficult and more convenient to touch on the concave. So it was easier on the convex surface. So that was mainly the reason why we did it in this way. But yes, in fact, with the model that Lina was showing these days of the dome made by paper, that you can make a big dome and then you can put the stars there and then you can really touch them in a concave surface. But for this small thing, because it's not larger than 20 centimeters diameter, then it's not very comfortable. So, and if you haven't seen the materials yet, they are outside, so you're welcome to go and see them and touch them. Thank you.
Okay, let's thank Amelia again. Our next speaker is Maria Beta.
Yes. Thank you. I am Maria. I am from Romania. I teach at Seika High School, and I want to present some activities from my science club. My English is very simple, sorry for this. Here is my school. We have nearly 1,300 students and 90 teachers. We have three type of classes at high school: humanity, maths, and IT, and science. Our curricula doesn't have astronomy at any level. So I try to teach astronomy during the science club and outdoor activities. Here are some activities from our science club. I learned about this during different training, teacher training session during the last years, and I try to apply them in my school. Every year, first week of April, named Science Day at my school, and here are the activities which we done this year in April with my students. Favorite activities measure the diameter of the sun. We do these activities with high school students and with students from middle school. It's a very, very simple activities, and my students love this. Every year in this activity participated more than 50 students. And other activities study the sunspots and period of rotation of the sun. We download the magnetograms from SOHO archive and analyze them, and here is the results from 2 of groups, and after the activity, we debate, we discuss about the results, we talk about the sunspots, how they form, how they move, and so on. On other activities is the solar system in the lab. This is activity for young students, led by high school students. They draw a solar system, made models, and talk about temperature of the stars, Hertzsprung-Russell diagram, and so. This year we have a project about impact craters. Here are some pictures took by my students. We made this project in our group, or 3 or 4 students. They worked separately 1 month before the presentation, and we made with different materials, with different balls, size, diameter, and we compare the results. And after the presentation, we compare our results with the moon craters. This year we participated at Eratosthenes experiment with my school at 21 March. We got very good results. We participated with more than 70 students. We don't have telescopes, but we are in collaboration with amateur astronomers, and we invite them, and so we have astro days, sun observation, and so different activities with them. A new one is the robot buildings. This year we made a firebot and Lego robots. This robot, it's a rescue robot, can detect where is the fire, where is the victim, can it send real-time image about the victims, can measure the pulse and the temperature of the victims. And here are other type of robots. We participated at World Robot Olympiad this year with this kind of robots. A very, very important activity was the CanSat project for us. We participated at 2012 European competition with Boya team. Here are my students working at Andoya. Here, the CanSat kit. We measure the pressure, temperature, and dust density in the air. During the landing from 1 kilometer altitude. Here are our results, the pressure and the temperature. We got a very, very good results during the landing, and our kit worked properly during the whole process. It was wonderful. After the CANSET competition, we attached our CANSET kit to a flying device and other type of devices, and try to measure the speed of air waves in the radio waves in the air. Here is the kit. We had two devices, emitter, receiver, like walkie-talkie, computers, Arduino board, and the sensors. Here are the sensors for pressure, temperature, and dust density. This is an outdoor activities. Here were the base, the emitter, and in different position we put the other walkie-talkie. The first one emitted a signal, the second received and sent back this signal. And the first one measured the elapsed times between the sent and received signals. So we got for every distance more than 3,000 datas. Here we made 5 measurements for different distances from 500 meters to 1 kilometer. The distances here are the base. So here is the results. We plot the datas, and we got a line. The tangent, the inverse value of this tangent is the speed of the air waves in the radio waves in the air. Here is our results for day 2. It's quite good. Amazing Science is the annual physics meeting for students. During these meetings, they present the results of their activity during the last school year. We have the webcam project, and here is the CANSET. This is a national meeting held by Bolyai University. Astronauts, we invited here astronomers and scientists. They present what is new in space research, so on. And if it's possible, we do telescope watching. And thanks.
Any questions? So are most of these activities part of the curriculum or extracurricular?
No, it's extracurricular activities. We don't have astronomy, just few lessons during the geography class at 5 to 3 or 5 lessons about Earth and solar system and any other. It's outdoor activities and extracurricular activities.
Any more questions?
Have you thought of including the activities under a different name? So maths, instead of calling it astronomy, call it maths, but do the activity and focus on the maths component of it. So you can still include astronomy in your curriculum. It's just not called astronomy, it's called something else. Yes, and astronomy is the vehicle.
When I teach movement in physics, I teach about movement of the Earth and planets, so on.
Yeah. Okay, great. Thanks.
Okay, let's thank Maria again. Our next speaker is Cristina Mariasa. Christina is going to talk about astronomy education for primary schools.
Hello. I would like to share with you some of my research work in primary school. I'm a primary teacher. So this is the structure of my presentation. The motivation for this work. The concepts of the astronomy are very abstract for little children. There are a few teacher training. The dissemination of practical activities is quite few, and we need science education. Our research question, we try to think what about the conceptual understanding of teachers and students, if they are agree with the described in the literature, and if the practical activities produce significant learning if the learning is effective. So we try to identify the alternative conceptions. We try to implement practical activities in primary school, the two first and 4 years of schooling, and verify if there's a change in the alternative conception. So we first validate some practical activities with the teachers, experienced teachers. Then we design a teacher training action. After that, the teachers implement the activities with the students in class. And then we assess the impact. We use a quasi-experiment design with the questionnaire, pre-test and post-test implementation. The participants are students. The mean age 8 years and 9 years. So what we think, there are need for prerequisites. The phases of the moon are very difficult to understand, so they first must learn to observe the moon, their motion, observe the sun and the moon in the sky at the same time, all the movements of the sun, the earth, and the moon. I know that the moon is lit by the sun and only that part is visible. Seasons, the seasons is already a subject very, very difficult to understand. So they first must learn that light rays travel in a straight line, the angle of the incidence of the rays, of the sun rays, and the change of the sun's path. They are not aware of that. Another prerequisite for the night and day cycle, they must know the Earth is spherical. They do know that. It's very easy that. But to think that the cause is the rotation of the Earth is not so quite easy. And they think the moon only appears at night. So what we do, some activities to find the movement of the Earth. This is with the teachers. They try to construct a model with a salad bowl and to mark the path of the sun. The red line is the previous ideas of the sun passes through the sky. There are two different groups, and the black dots are the real sun marks that the view of the sun in the sky. Okay, so they contrast the previous ideas with the sun path, and they they knew they were wrong. This is the children doing the same thing. And the previous ideas of the children, the black line of what they think the sun, the path of the sun is, and then the registration of the sun dots, the path of the sun in the sky. Another activity is what happens to our shadow at different hours. They mark the shadow of the sun and then again. The same activity they implement with the children in class. The children are drawing the shadow, and the shadow in 3 times, different times. And the children look at the shadow and see the difference. Another activity was the phases of the moon. They tried outside with the sun and a ball. The ball is the moon, and they are the earth. They must turn and see the phases of the moon. Now is the full moon. The children are trying to do the same. Now is a question: where are the stars during the day with the stellarium? We take off the atmosphere and they send the sun and then the stars. And now it's a game with space technology. What is this for? I would like to play. You'd like to play with me? Is there space technology behind this object? You know, this object is sterilized object to sterilize the containers for babies, milk babies. Okay, was invented for space technology. This another one, contact lenses. This, okay. This object, is there space technology behind? Yes, was developed by NASA. Another one. Okay. No, not going. Stop. Yeah. Stop going.
Did it crash? Okay.
Oh, it's okay. Yeah, okay. Another one developed by ESA. Oh, the questionnaire. Some of the alternative conceptions identified in teachers' questionnaire, and in students is almost the same. Another one, and we can see the progression after the implementation of the training courses. The registration of the sun and the importance. When we ask to draw the moon forms, they do the full moon, the most visible on the media, in the media. Another one with the sun in the winter and summer. And the conclusions, we can conclude that the training course and the implementation activities is very important, and they are show a greater tendency to respond in a scientific way. Okay. Okay, thank you.
Questions? So you investigated the kids' understanding of astronomical phenomena. Were you content with their current knowledge, or do you think it needs a lot of improvement?
I think it's an improvement after the implementation of the activities with the teachers and with the students. Yeah.
Was it then up to the desired level?
Sorry.
After the instruction, was it then up to the level that you want for the kids? Or do you think there needs to be improvement in astronomy education?
Yes. There will be an improvement. Yes.
Other questions?
Congratulations. First is a suggestion that you have to publish this work as an article, okay? The full work, okay?
Yes.
And the second one is that you have to be careful about the data gathering because of the drawings of the students. Because you have practical activities, hands-on activities in the area of the school. Is it different to see the conceptions with the drawing and with the actions, right?
Yes.
So is it as a suggestion to combine this data and to increase the discussion?
This is a part of a
Yes,
PhD,
congratulations.
just a little part.
Yes, it's a very interesting thing, but it's a challenge to see how does the students see in three-dimension activities, right?
Yes.
Let's thank Christina again.
Okay.
Thank you.
Thank you.
Our last speaker is Naoki Matsumoto.
Yes, this one.
Naoki will talk about ICANN, the Constellation camera system for education.
Thank you. Hi, it is last speaker. Hello, my name is Naoki Matsumoto, a HO teacher of Japan. I'm glad to join GHOU, and I'm glad to see you. I am an earth science teacher of Keio Senior High School. My school is one of the oldest private schools in Japan. And my boss gave me sabbatical leave, 1 year sabbatical leave. This is my class timetable in this year. It's very clear. And it was a result of evaluation of my educational activities. My activities split is based on hands-on universe. For example, my students made it. So I want to say gratitude, global HOU members. You let me here. Thank you. Thank you very much. Obrigado. Arigato. In this year, I belong to National Astronomical Observatory of Japan. And I am researching astronomical education under the guidance of Dr. Hidehiko Agata. This talking, I'll attempt to introduce ICAM. ICAM is interactive camera network. It has high sensitive camera. It can describe constellations, star clusters, and the Milky Way. We named ICAN also. We hope that every student can use this camera easily by simple user interface, even if elementary students. Our purpose is very simple, to provide real-time night sky into classrooms. Usually, classes of the school are carried out in the daytime. So teachers cannot provide real celestial objects. However, If using internet, students can learn astronomical subject by real-time constellations from night side of the Earth. Our leader is Dr. Takehiko Sato. He is a professor of JAXA, Japan Aerospace Exploration Agency. He belongs to ISAS, Institute of Space and Astronautical Science in JAXA. At first, we developed remote telescope controllable by internet browser, named the Internet Observatory. We installed one on Ghana. We continue its maintenance, so it is available now, even over 10 years past. This is inside of the internet telescope, and open sliding roof automatically. It is a moon and Sun and Jupiter. Here is a composite image. Next, we challenged next step. We want to be helpful for more students using experience of the internet telescope. In an education guidance by Japanese Ministry of Education, fourth grade elementary school students learn first astronomical subjects. Brightness and collaboration of fixed star and its moving. All students learn these subjects, however, stars cannot observe in daytime. So almost teachers say it is homework. But students cannot identify stars and cannot express a position of a star without training. For students, write to their worksheets something and submit it to teacher without understand. It is not learning. Therefore, we prepared a wide field and high sensitivity camera. It is controllable pan and shoot via internet using internet browser. And it put inside of clear acrylic dome against all weather. It is AEAM. We put AEAM cameras at 8 sides of the world. Japan, Hawaii, North America, Spain, Canary Islands, and Chile. This network provides night sky anytime. Let's use internet. Let's use AEAM. Open. Yeah. Moving this side. Thank you. This is top page of AEAM website. You can searching by keyword I-CAM or I-CAM and JAXA. Probably, yes, you find this page. Click English page. English page is here. This picture shows this picture shows current night side of day side. It helps you choice of observation site. And this image shows you currently sky simulated. You can choose observation site, clicking this circle of this image. I'll choose Subaru site. Oh, opening. This is top of Mauna Kea, next by Subaru. If this site is free, you can control, okay, you can control 15 minutes without reservation. Click here to use as a guest. And next, choice object. For example, Cassiopeia. Next, click Get Altitude to get altitude and azimuth angle. Here, and go. Wait a minute. At first, we used the real player system, but it needs additional software. So we use pushing JB. It is a very simple way to stream night picture. Go. Oh, moving. This is moon. The picture sent by about 5 seconds. You can find Cassiopeia. Yeah, you can also move direction button. At first, choice width and next direction button. Okay, please use it. This is not my presentation. Thank you. Yes. Next, I will show one example of classes using ICANN. We used ICANN for the learning of brightness and colors of stars on elementary school 4th grade. This subject requires also to make skill of using star chart disk. It spent almost 3 hours in usual class. We designed 3 hours classes using ICANN. The first hours, I'm finding the summer triangle from stream image and understand how to use star chart disk. Next second hour, I must understand relation between real time and image and star chart disk. And the third hour, let students control ICANN and let identify the constellation of ICANN images using their star charts. Usually, these studies, students use textbooks image. They are almost different from fact night sky because stars are moving. And this observation is almost lonely work. Students have to find only one skill. However, using ICANN, students can observe night sky with other students. They can understand together. These classes were carried out before summer vacation. We performed the questionnaire after summer vacation. Okay, no time. In conclusion, we developed and the constructed internet constellation camera ICAM. The ICAM enable learning with real-time night sky in daytime classes. The learning using ICAM can improve the observation skill of students, and the learning using ICAM lead students to the real observation experience. Yes. Thank you. Thank you very much.
We have time for half a question. No questions? Okay.
Please, simple English.
Actually, are curriculum materials activities on your website in English? And then second question, how come Nucleo hasn't used this much? This seems crazy. Nucleo breaks my heart. But curriculum activities too.
Curriculum Japanese?
Or English activities?
English activities.
Yeah, for ICAM.
Yeah. I don't carry it out in English classes. Please. Let's make it. Yes. 英語を書きますか？カリキュラムで？Yeah. Say to make curriculum in English. So let's make it.
Okay, let's thank Naoki and the other 5 speakers of the session. And Rosa has 2 announcements.
No, it's just to say that we will have one announcement from Pedro after lunch, so you have to come back. It will be very important. And also, we have a video to show to Mike Simmons from one of the winners of the contest. It was Francisco, the boy that we saw today in the morning. He made a special poem who won a prize, but he made a special video because he couldn't be here with his mother. So he made a special video for Mike that I'm going to show right after lunch. So don't be late. We reconvene at 2:30. Also, we have, after the discussion session, we have a session to discuss astronomy education in general. Just perhaps we can make, a set of sentences that we can carry out all next year with us and discuss a little bit what we're going to do to attract the attention of people that don't know we exist for next school and calendar year. And then we have the Global Hands-on Universe General Assembly. Everybody is welcome to come. It's not boring, I promise you. I think it's the only General Assembly that is not boring. We handle all the reports and accounts in 2 minutes, and then we talk about fun stuff, okay? Yeah.
As I've been watching these reports, I've been taking notes on my computer, and I am hoping that you will join us and we can nominate you to be members of GHOU, because I've enjoyed so many of these things, and I think you should join us and increase our membership. So I'm inviting you all to the meeting so that you can get sort of a taste. And then I've just been taking notes of people that I really hope will join us in the organization itself. So thank you.
So 2:30. Enjoy your lunch.